A good day to everyone who's watching. In our lesson 7 today of number systems, we are going to talk about the H.C.F and the L.C.M. So our example 1, find the L.C.M and the H.C.F of 12 and 42. Now the H.C.F, highest common factor, sometimes they can call it the greatest common factor. Then method 1, we are going to first prime decompose the 12 and 42. So by 2 I get 6, by 2 I get a 3, and then by 3 I get a 1. So 12 is equivalent to 2 power 2 times 3 power 1. Then the 42 prime decomposing, this is 2, that is 21, divide by 3 to get 7, then divide by 7 to get a 1. So the 42 is equivalent to 2 power 1 times 3 power 1 times 7 power 1. So to get the highest common factor, we look at the products of the primes. Here I have what is appearing here common is the 2 and the 3, 2 and the 3. So I have 2 times the 3. Then I take those that are having the least power. So the 2 here and the 2 there, this 2 power 1 is having the least power, and then the 3 power 1 is having the least power. So when I multiply that, that is 2 times 3 to get 6. Then to get the LCM, I look at the products of the prime factors, those that are common and those that are not. So that is 2 times 3, then times 7. 7 is appearing on the other. In other words, the 7 for this one would have been 7 power 0. Then I look at those powers that are having, those numbers that are having the highest power. So the 2 here and there, this one here is having a power 2, power 3, then the 7, the highest, is having a power 1. So I multiply 4 times 3 times 7 to get me 84. So alternatively, we can combine the two in the ladder method, the two values whose LCM has been asked. So I get, if I'm finding the LCM, I get any number that can divide these two, and that one is a 2, can divide 12 to have a 6, and divide that one to get 21. Then 2 still can divide any of those two numbers, that is 2 can divide 6 to get 3, but I keep the 21. 3 can divide 3 to get 1, can divide 21 to get 7, then 7 divide 7 to get 1. So the LCM is 2 times 2 times 3 times 7, which is 84, as from this other previous method. Then if I'm finding the H.C.F, I can also use the ladder method. So I need to get a prime number that can divide both of the two numbers. So the 2 divides 12 to get 6, divides 42 to get 21. Now a 2 can't divide 21, that is why I'm not going to use it. I skip to the next prime number, which is a 3. 3 divides that to have a 2, 3 divides that to have a 7. Now, there is no prime number that can divide 2 and 7 at the same time. Then I stop there and I say that my HCF is equivalent to 2 times 3 to get 6. Another method for finding the HCF is by listing the factors of those numbers there. For example, the factors of 12, we have 1, 2, 3, 4, 6, and 12 itself. Then factors of 42, we have 1, 2, 3, 6, 7, 14, 21, and then 40, 42. Now, we check the common factors. There is a 1, 1 is there. There is a 2, 2 is there. There is a 3, 3 is there. There is also a 6, and 6 is there. So the common factors there, we have 1, 2, 3, and then 6. Now we choose the highest to make up the highest common factor. So the highest there is a 6. So example 2, find the LCM and the HCF of 30 and 45. We have said we prime decompose those two numbers there. I begin with the 2 to get 15, 3 to get 5, 5 to get 1. So the 30 is equivalent to 2 appearing once, 3 appearing once, and then also 5 appearing once. Then 45, prime decompose. This is a 3, 15, a 3, 5, 5, 1. So I'm having my 45 is equivalent to a 3 appearing twice and a 5 appearing once. So after prime decomposing, to get the HCF, we have said you look at the prime factors that appear here and there. So there is a 3 and a 5. Then we take the least powers. So 3 there has a power 1, but the 3 there has a power 2. So I'm going to take that one with the least power, and also the 5 with the least power. So any number power 1 is that very number. HCF has 15. So to get the LCM, we said this 45, there is a 2 power 0. So the 2 times the 3 times the 5. Now there we are going to choose these primes having the highest power. So the 2, 0 and 1, we must take that one of 1. The 3, that one of 2. And the 5, that one of 1. So this is 2 times 9 times 5 to get 90 as the LCM. So the other alternative, find the LCM using the ladder method. We pick a number that can divide any of the two numbers. That is a 2 can divide 30 to have 15. I keep the 45. 3 can divide 15 to get 5. 3 divides 45 to get 15. 3 can still divide 15 to get 5. So I keep the 5 there. Then 5 divides to get 1, 1. Then I have my LCM as 2 times 3 times 3 times 5 to get the 90 as here. Then to get the H.C.F, I pick a number that can divide these two numbers at the same time. So that is 3 divides 30 to have 10, divides that to have 15. Then another prime number that can divide 10 and 15 at the same time is 5 to have 2, and then to have 3. So the HCF becomes 3 times 5, which is 15. So example 3, find the LCM and the H.C.F of 12, 16 and 24. So ladder method. I'm going to use the ladder method. Finding the LCM, I get a number that can divide any of the 3. So 12 divided by 2, that is a 6, 8, and then this is a 12. Still 2 can divide 6, can divide 8, can divide 12. Still 2 can divide 4 to get a 2 and a 3. Still 2 can divide 2 to get a 1, and then I keep the 3. Then 3 divides 3 to get 1. Then my LCM is going to be equivalent to 2 times 2 times 2 times 2 times 3. And when you multiply that, you should be able to get 48. So to find the H.C.F, we get a number that can divide all the 3 at once. 2 can divide 12 to have a 6, 16, 8, 24 to get 12. Still 2 can divide to get a 3, 4, and then we get a 6. Now there is no number that can divide 3, 4, and what? And 6 at the same time. So the H.C.F is equivalent to 2 times 2, which is 4. Then to go back here, just a number, someone can say that 1 can divide 3 to get 4 to get, yes, but when you multiply 1 times anything, is that anything? So that is why I say from here that there's no number that can divide all the 3 at once. So the H.C.F is 4 and the L.C.M is 48. So try out those numbers and then you'll be giving me a feedback.